Hello, Math 1050. This is Mrs. Bricky, and this is 1050 section 1.2, applications with linear and rational equations. We have a total of 3 topics in this section. We're going to do 2 examples of each, so a total of 6 problems altogether. First 2 examples are going to be solving a word problem with 2 unknowns using a linear equation. So I think for the most part, these are pretty easy to set up and solve. A little bit of advice I would make for you is that use variables that kind of go with the words that they're representing. So, for example, this problem is about hamburgers and cheeseburgers. So I wouldn't use X and Y. I would just use H for hamburger and C for cheeseburgers. That way, when you get to the end of the problem, you can just make sure that you've solved for the right thing. So our question here that we're going to try to answer is how many hamburgers were sold on Saturday. So now I know my goal is to solve for H. So if you use X and Y, sometimes you lose track of what you're solving for and you answer the wrong question. So we've got a local hamburger shop. They sold a combined total of 700 hamburgers and cheeseburgers. So if I add together the number of hamburgers and cheeseburgers, it's equal to 700. There were 50 fewer cheeseburgers sold than hamburgers. So they sold more hamburgers, fewer cheeseburgers. So I'm going to write the equation H minus 50 is equal to C. So sometimes when it's a less than or a fewer sentence, it's a little bit tricky. Is it H minus 50 or is it C minus 50? I would write your equation the way you think it is and then read the sentence again and see if your equation makes sense for the sentence. There were 50 fewer cheeseburgers. So this number has to be less. So subtracting 50 from H seems like it's going to work out. And then to solve for H or C, I would probably just use some substitution here. We know what C is equal to. C is equal to H minus 50. So we're going to sub that in to the other equation for C. So I'm going to put this where the C is. So that gives me the equation H plus H minus 50 is equal to 700. So to solve that, I can add the 50. So now I have 2H, I just combined those together, is equal to 750. So if we divide, we find that the number of hamburgers is 375. So, when you get to the end of a word problem, always make sure you found what they were asking you for. It would have been possible for us to find C, and in that case, we may need to go back and substitute to get the one that we're looking for, but for this one, we were looking for the number of hamburgers, and that's what we found. Okay, a washer and dryer cost $600 combined. So I'm going to do W plus D is equal to 600. The cost of the washer is 3 times the cost of the dryer. So the dryer is less expensive. The washer costs 3 times more than the dryer. So the washer is 3 times more than the dryer. So W is equal to 3D. So again, I would probably solve this using a little bit of substitution. We know what W is, so we're going to substitute this for W. I'm going to put that in right here. So my equation, now that I'm substituting in, becomes 3D plus D is equal to 600. Or in other words, 4D is equal to 600 when I combine those two together. And now when we divide, we get D is equal to $150. It did ask us what the cost of the dryer was, so that is the correct variable, the correct answer. All right, so that was our first topic. The next 2 topics are a little bit trickier, and we're going to use a little table setup to help us solve them. To help us, keep track of all of our information. So this first problem is two cars. They're leaving towns that are 480 kilometers apart, and they're traveling towards each other. One of the cars is traveling slower than the other by 10 kilometers per hour. In 3 hours, they meet, and our question that we're trying to answer is that what is the rate of the slower car? So when you're doing these distance rate times problems, you want to remember this little formula: rate times time equals distance. So my table is kind of set up with that rate multiplied by time is equal to distance set up. So let's think about car number one. Let's see, I'm going to write it here. We don't know how fast car number one is going, so I'm going to just call that X. But we know that the car is driving for 3 hours. Both of the cars are driving for 3 hours. So our situation is that we've got a city over here and a city over here. The cars are, driving towards each other, and after 3 hours, they meet. So the first car drives for 3 hours, and the second car also drives for 3 hours. They don't cover the same amount of distance, though, because they're not going the same speed. So this time for car number one is 3 hours. Well, that means that the distance that car traveled is rate times time. So it's 3x. For car number two, we don't know its speed again, but we do know something about its speed. We know that the speed of the second car is 10 kilometers per hour less than the other speed. So I'm going to call this x minus 10. And again, it also travels for 3 hours. So the distance that car travels, if we multiply these two things together, and this is a binomial, so we would need to distribute that 3 when we multiply it. So this will be 3x minus 30. So I have used this table of value to kind of table to organize all of the information I have so far. There's one other bit of information that we have. The distance apart that the cars started was 480 kilometers. So that means my total distance is 480. So we're going to set up a little equation, and then we can finish and solve our problem. If I add these two distances together, that has to equal 480. The distance that car number one traveled plus the distance that car number two traveled is equal to 480. So 3x plus 3x minus 30 is equal to 480. So that's 6x, and I'm going to go ahead and add that 30. 6x is equal to 510, so x is equal to 85. Now, that is the value of x, but this is a great example of when in a word problem, you need to really pay attention to what information the problem is asking for. Our question is, what is the rate of the slower car? Well, x is the rate of the faster car. X is car number one's speed, but this is the slower car. So our answer would not be 85. Our answer would be 75 kilometers per hour. So make sure you really think about if you answered the right question at the end of a word problem. Let's try a variation of that. Manuel drove to the mountains last weekend. There was heavy traffic on the way there, and the trip took 10 hours. So on the way there, it took 10 hours. When Manuel drove home, there was no traffic, and the trip only took 7 hours. If his average rate was 18 miles per hour faster on the trip home, how far away does Manuel live from the mountains? Okay, well, his rate is faster on the way home. So I'm going to call the speed or the rate on the way there, x, and on the way home, it's 18 plus x because he's going a little faster. So remember, rate times time gives us distance. So the distance, rate times time, is 10x here. And here, if we multiply x plus 18 by 7, we get 7x plus, and we got to distribute that 7 and multiply it by 18, so 126. So on this one, sort of the variation is that he's driving somewhere. So he's driving somewhere, and then he's turning around and driving back. So the trick for your equation set up here is that these two distances are equal to each other. The way there and the way back have to be the same distance. So my equation that I can solve for x is 10x is equal to 7x plus 126. So to solve that, I'll subtract the 7x to get 3x is equal to 126. And so when I divide by 3, I get x is equal to 42. Now, looking back at my table, this is a speed. This is his rate of travel, and that is not what my question asks me. My question asks me, how far away from the mountains does he live? Well, it's basically asking me for this distance. Only in one direction, though. On the way there, on the way back, he travels the same distance, and that distance is how far away he lives from the mountains. So if this rate is 42, then the distance would be 10 times 42. So he must live 420 miles away from the mountains. All right, so that was the second topic. The last topic is computing a percent mixture. So we're going to do two variations on this one as well. The first one is literally a percent mixture with an acid. And then the second one is a type of percent mixture problem that actually has to do with interest. All right, so suppose 7 quarts of a solution that is 40% acid is mixed with 1 quart of a solution that is 17% acid. We have two questions that we have to answer here. Our first question is, how many quarts of acid are in the resulting mixture, and what percent of the resulting mixture is acid? So let's use this table to help us organize our thoughts. So we've got two solutions here. So I'm going to call this first one solution number 1. For solution number 1, we have 7 quarts, and it is 40% acid. So we have a quantity or an amount of 7 quarts, and the percent acid is 40. Now I'm going to put that in decimal form. So just remember, if you have a percentage like 56% in decimal form, that would be 0.56. So we move that decimal place. We move that decimal 2 places to convert a percentage into a decimal. And when you're doing computations, you always want to use the decimal form. So if this mixture is 7 quarts and 40% of that is acid, we can actually multiply those two together to get the amount of acid in quarts. So 7 times by 0.40 gives us 2.8 quarts of acid. So basically these solutions are acid that's been diluted. So to make that 7 quarts of 40% acid, you would use 2.8 quarts of acid and then fill the remaining amount up with water to dilute it to that 40%. All right, so solution number 2, we have some information about as well. Solution number 2, we are only using 1 quart, and it is 17% acid. So if we multiply those two together, we would get that that's 0.17 quarts of acid, and the remainder would be water. So when you mix this together, if you have 7 quarts of one solution and you combine it with 1 quart of another solution, you do have 8 quarts total. That is the total solution volume. We don't add percents together, though. That's not how that works. A percentage tells you, how much of that solution is acid. So you don't want to add that column together. You just want to add the first column and the last column because those are amounts and we can add together amounts. So this last column, if we add it together, 2.97 quarts of acid. This is just the total amount of acid in that new solution. So we have 2 questions that we needed to answer. The first one was how many quarts of acid are in the resulting mixture? And we have that answer right here, 2.97 quarts. Our second question is about a percentage. What percentage of the resulting mixture is acid? Well, to calculate that percentage is calculated as part over whole. So the part of the solution that's acid is 2.97 out of the 8 quarts. When you do that computation, you're going to get a decimal value, 0.37125. And it's asking us what percentage is acid. So we need to report our answer as a percentage. So we would say that it's 37.125%. So that would be the answer to the second question. All right, so that was computing a percent mixture with acids, with solutions, but we can use that same idea of percent mixtures with investments and with money. So we've got Frank investing money in 2 purchases. He purchased a certificate of deposit for $2,000 that paid 4% interest per year. And he purchased a $5,000 corporate bond that pays 2.5% interest per year. So for this problem, we are going to use simple interest formula. Percent times rate times time gives you interest. I'm sorry, I said percent. Principal, oh my gosh. Principal times rate times time gives you interest. So the amount of money multiplied by the interest rate multiplied by the amount of time it's in the account. So I have my table set up, principal, rate, time, and interest. So if we multiply these together, we get the amount of interest earned. So we have 2 goals that we want to calculate here. We want to calculate the amount of total interest that was earned at the end of 1 year. And we want to calculate the percent interest for his total investment. So for the CD, that was a $2,000 principal investment. It's paying 4% interest per year, so that's 0.04. Remember, move the decimal 2 places so we get that 0 in front of the 4. And the time that we're dealing with here is 1 year. So if we multiply that $2,000 by that 0.04%, that means that the interest earned on that account for that 1 year was $80. For his bond, he invested $5,000. The interest rate is 0.025. And again, we're having a time frame of 1 year here. So if we multiply that principal rate and time together, we get that he earned $125 on that bond for that first year. All right, so we need to answer 2 questions. Total interest earned. Well, you can see the interest amounts earned by both of those separate accounts, so we just need to add those up to get the total interest earned, so that was $205. And then it also asks what percent interest was he earning on his total investment. Well, we can't add percentages or rates together, and this was concurrent, so we definitely don't add time together. It was the same year. It's not 2 years now. But we definitely can add up his entire or total investment. His total investment was $7,000. So if we want to calculate his percent interest for that total investment, for calculating percents, you're going to do part over whole. So we've got $205 of interest earned on a whole investment amount of $7,000. If we calculate that, we get 0.02928. So if we convert that into percentage form, that would be 2.928%. So that would be the answer to our second question. Now, just something to point out to you, when you're calculating these final percentages, you would expect the final interest rate to be somewhere between these two. If one of your accounts is earning 4% and one of your accounts is earning 2.5%, you would expect your overall interest rate to be somewhere in between there. And that's the same idea with these acid mixtures. If you're mixing 40% acid with 17% acid, you would expect that overall percentage to be somewhere between the two. If there's more of the 40% solution, you would expect this to be closer to 40. If there was more of that lower percent, you would expect it to be closer to that lower percent, but definitely will always fall in between those two numbers. All right, so that was section 1.2. Let me know if you have any questions. Thanks a lot.